Hello, this is a podcast explaining the transforming y equals x, so our parent function for a line, to map on random linear graph. What this app does is there's two graphs going on here. We got the parent function, which is in green. We can shift and change the slope of our parent function. So the vertical shift being our y-intercept as we change this. Notice the equations down here are going to change as well, but we can go ahead and translate if we want. Our parent function. Notice there's a nice gray parent function that stays, that is our reference. Okay, we can also change our slope of our transformed parent function. And when we're done with our transformation of the parent function, we want it to go back. We have the reset to parent sequence here. So when I click that, it just sets our y-intercept to 0 and our difference back to 1. So what this does over here is that the red is a random linear pattern that as we set the y-intercept or the b, notice it just jumps around. So we have different y-intercepts. There can be decimals, which are in quarters. So it could be, this is negative 4.25. Not crazy decimals, but decimals nonetheless. So our students, aren't super fans, but they need to get there. So I'm going to leave the y-intercept there at negative 3.5. The difference, if we click that, it'll just change our difference. So now the idea behind this app is, what's the equation of this line? So right now we can see the equation of our parent function. So the way that I, in my class, have been teaching how to write an equation for a line is our first term, or in linear instead of sequence terminology, it's going to be our 0th term, or our y-intercept, plus our difference times x, which is our slope here. So then what we can do is, trying to map onto this, students need to see that this graph needs to be shifted down 3.5, so then our y-intercept is going to go to 3.5. Get it there. So there's 3.5. Notice they match up nicely. Now our slope, we need kids to understand what our slope is. So if we go to negative 3.5, and as we increase by 1, looks like we go to negative 3. So we must have a slope of 1/2. So I'm going to change our slope then to 1/2. Oops. Oh, that's negative. There's our 1/2. And notice we got the line to map up on this line. So we can see the equation of the red line. It's negative 3.5 plus 1/2 x, or the commutative property, and seeing the mx plus b form, I just switched the order. 1/2 x plus negative 3.5, or minus 3.5. So we can either have them, for whatever reason, I'm thinking worksheets might be pretty easy to make with this, but it might just be a new problem like this, and they may have to write the equation of the red line, maybe explain what they would have to do to the parent function to get it to map on to this red equation. Also, they can see they need to be able to analyze slope and whatnot, but they can do, for exploration reasons, also understand that they need to shift up, say 5, looks like 5.25. So now we got our y-intercepts to match up. Then the slope to map onto this one. Then looks like it's a slope of, that's 5.25. Looks like we go up to 14.75. So that's what, a difference of, or a slope of 9.5. I hope my math's right. So I'm going to move this to 9.5. Oh, I was right. So there's my slope of 9.5. So I got the lines to map up there. Okay, so cool app here to just randomly create a sequence that students need to analyze and talk about transforming the parent function to map onto this red random function. So nice way to work with linear equations and graphing.